In this video, I'll be teaching you how to use the Omaka's square root of surd factorization theorem to obtain the value of the square root of a surd. Previously, I already released the video on this powerful theorem, the Omaka's square root of surd factorization theorem. So we should be using the knowledge there to deal with this problem. You can go through the GMAS 41's YouTube channel and you would find the video which I released on this theorem. Alright, we have 7 minus 4 root 3. We have to find the square root. We shall make this equal to plus minus and then square root of x, then plus square root of 1. But please, I'm not going to put plus here. I'm going to tell you this. The mathematical sign between square root of x and square root of y depends on the mathematical sign that you have here. In this case, this is minus. Therefore, it's going to be minus here. Is that okay? Suppose that the sign here is positive. Alright? Then, here it's also going to be what? Positive. Having done this, the next thing we're going to do is to label this as A, B, and what? C. Because according to the Omaka's square root of surd factorization theorem, we are expected to seek for the value of b squared times c divided by 4. The value b squared times c divided by 4 is very important to this method because it's the factors of this value that simply gives us the value of x and y. So let us go for it. B squared times c divided by 4. This is going to give us 4 squared times c is 3. 4 is b. Take notes. Is that okay? So it's going to be 4 squared times 3 divided by 4. If you work on 4 squared, you get 16 times 3. You get 48 divided by 4. That is going to give us 12. Or you simply do 4 squared 16. Divide that 16 by this 4, you get 4. 4 times 3, you get 12. Now this number, which is the value of b squared times c divided by 4, according to the Omaka's square root of surd factorization theorem, we need to get 2 factors of this b squared times c divided by 4. Those 2 factors, as long as you add them up to get the value of a, which is 7, these are the values of x and y. So I would like us to work on this together. If we say that the factors of 12, which we may use here, is 1 and 12, because 1 and 12 are 2 paired factors of 12. These 1 and 12, if you add them together, you cannot get 7. Therefore, 1 and 12 cannot solve this problem for us. Let us think about 2 and 6. These are paired factors of 12. But 2 plus 6, if you add them, you cannot get 7. Therefore, 2 and 6 can't solve this problem for us. What about 3 and 4? Correct. 3 and 4 are the paired factors that can solve this problem. Because if you add 3 to 4, you are going to get what? 7. Therefore, on the basis of that, we could say that our x is equal to 4 and y is equal to 3. These are the factors of 12, which must be equal to x and y. If you add them to give you 7, it must satisfy that condition that the addition of these factors of b squared times c over 4 must give you a. Having done this, our problem is solved. We could just simply go back. The square root of this term given to us is equal to plus minus, open bracket, square root of 4, because x, we are taking it to be 4, and then minus square root of 3, because we are taking y to be 3. Please take note, there is no rule that x must be 4 and y must be 3. It can be interchanged. Taking x as 3 and then y as what? 4. You still get the same result. Okay, therefore, the square root of this term will be equal to plus minus square root of x, which is square root of 4, minus square root of y, which is 3. If you work in this, square root of 4, 4 is a perfect square, so you're going to get plus minus 2 minus root 3. And of course, this is the value of the square root of this term. Is that okay? Now, I want to say something quickly, please. You see that this is plus minus. Plus what? Minus. It simply tells us that there are 2 values here. One, which is plus 2 minus root 3, and the second, which is minus 2, right? This minus will affect this one to change it to what? Plus. So you're going to have minus 2 plus root 3. That is if you take the negative value. But the idea here is this. We always go for the positive value of the square root of a number. The reason is that the square root of a number cannot be negative. Is that okay? It's always positive. So although we have these values here, if we are to pick only one of the value, we could conclude that square root of 7 minus 4 root 3 is simply equal to the positive value of this term. And the positive value of the term is positive 2 minus root 3. And this is the answer. Again, I'd like to say this quickly. Suppose you had picked that of negative here. If you picked that of negative in this case, you know that this will become minus 2. And this will become what? Plus root 3. If you work it out, you are going to get a negative result. Therefore, negative of this is not expected to be our final answer. But what if you had interchanged x and y, giving y 4 and x to be what? 3. You know that in that case, we are going to have square root of 3 minus square root of 4, where square root of 4 will now produce 2 for us. Hence, we'll be expecting to get square root of 3 minus 2. That term alone, square root of 3 minus 2, is a negative result if you pick positive square root of 3 minus 2. Therefore, in that case, the value we're going to pick will be negative square root of 3 minus 2. Because if you work out that negative, open bracket, square root of 3 minus 2, what are you going to get? Automatically, sign inside the bracket will change. So it will now become 2 minus square root of 3. But in either way, that's why I told you there is no rule that x must be 4 and y must be 3. In any way you go by it, you still get the positive results to be this. I hope you enjoyed this wonderful method of obtaining the square root of solid number, the Omaka's square root of sort factorization method. Please subscribe to my channel, turn on the notification bell, share the GMAS 41's videos to your friends and classmates. Invite them also to subscribe to GMAS 41's YouTube channel. We are always committed to give you the best in order to contribute to your academic pursuits. I hope to see you in our next video.